Good day, everyone, and welcome to the Environmental Models and Statistical Analysis to Support Decision-Making for Natural Resources conference call hosted by Scott Harso. My name is David, and I am your event manager. During the presentation, your lines will remain on listen only. If you require assistance at any time, please key star and 0 on your telephone, and the coordinator will be happy to assist you. I would like to advise all parties that this conference is being recorded. And now, I'd like to hand the call over to Scott. Please proceed, sir.
Thanks, David, and welcome everybody. Appreciate you taking some time out of your busy schedules to share this presentation with us and to take your minds off of anything that says COVID or pandemic for an hour or so. We will be presenting today environmental models and statistical analysis to support decision making for natural resources. And Dave, Mel, if you want to advance one. Our typical housekeeping items on here, your lines are muted, and we will allow and encourage questions to be submitted using the Q&A function within WebEx, and then we will save some time at the end of the presentation and get back to the question and answer session at that point. We would ask that you would also give us your name when you do submit a question, so in case we need to follow up afterwards to give you a more complete answer than what we can do on the call, that we would have that contact information. So, thank you. A brief agenda here. We will give you some introductions into our speakers. Randy will give us a core value moment. We'll do our presentation and then question and answer as time permits. For introduction to our two presenters today, I'll start with Mel. Mel Vargas is a project manager and subject matter expert in watershed and stormwater management with our Austin, Texas office. Mel brings 28 years of experience with water quality management at local, state, and federal level projects. And Randy Palachek is a senior project manager with over 32 years of experience dealing with biological sampling, eco-risk assessments, remediation of CERCLA and RCRA sites, water quality standards, watershed assessment, water quality modeling, regulatory analysis, permitting, and the like. With that, I will turn it over to Randy for a core value moment.
Thank you, Scott. We wanted to focus a little bit on innovation today, and that's why we'll be presenting on our decision support tool. So Parsons strives to use innovations any way we can, and especially in aiding multi-criteria decision making, which is needed a lot of times for resource management to try to explain these models and high-level statistical analysis in a simple type of a format so that the average resource manager, et cetera, can understand what these mean and directions for the site. Go ahead, Mel. Go ahead and advance to next. So we're not going to go into a detailed modeling or detailed statistical analysis today, which might tend to put some people to sleep, but instead we're going to focus on and just kind of give a little background, a high level on some of the models that Parsons typically uses in the work that we do. For example, in streams and rivers, Parsons will use the EPA Qual 2E model, Dynhide models, HSPF, SWAT, as a stormwater runoff model. Many of you have probably heard of these before. Also the EPA WASP model series. Lakes and rivers, we'll use Dynhide, again, SWAT for runoff models, HSPF, EFDC, and then in modeling a lot of bays and estuaries, again, Dynhide, TextBlend, RMA series of models from Corps of Engineers, EFDC, POM, etc. In addition to surface water quality type models, We also have ecological and habitat models that are frequently used, such as PHAB, SIM, ToxiWasp, food chain models, or just a few of the examples. Go ahead, Mel, advance. So in addition to that, obviously, there's a whole suite of groundwater models that many of you are probably familiar with, and we won't go into the details on those, but again, those are used to evaluate movement and flow direction, velocity, discharge rates, especially between two or more systems, such as going into, through the aquifer or discharging into a river or a stream, and possibly looking at contamination there. Their models are also used to identify data gaps, especially during site characterization work. What else we need to collect? It gives us some uncertainty values, in addition to being able to give us some impacts of potential contamination. So they can be used heavily in terms of designing and looking at performance of remedial systems, to look at leachability from surface soils into groundwater or surface water, look at measuring regulatory compliance, in addition to also being used for vapor intrusion type modeling. Okay, Mel? To hit the high levels on environmental statistics, getting into more of the complex statistical ones besides just the typical means and other histograms and other type of statistics that we use. We'll also utilize positive matrix factorization, principal component analysis, and these are used to measure and characterize the appropriate contamination to various sources when multiple sources are unknown and the composition is unknown. For example, we've used these to try to quantify various sources related to trace elements in soils from historically contaminated remedial residential sites, looking at them for using for PCBs, congeners, dioxin congeners, various PAH isomers. In addition, another tool we use is structural equation modeling, or SEM. It's more of a multivariate statistical modeling approach that will look at how these various environmental factors can relate, such as an example we'll show for dioxin levels and bioaccumulation in the Houston Ship Channel. We've also used it to discriminate impact of freshwater inflows on tides, agricultural and industrial water withdrawals and releases, and how that's impacted on salinity. In addition, conical correspondence analysis and related ordination techniques have also been used in order to try to look at occurrence and abundance of biological species to these environmental factors and stressors, such as in a natural area, we've got terrestrial plant health versus potential contamination and versus what the risk assessment might predict. And so those are just some detailed, high-level, complex statistical tools that are sometimes hard to explain to the average person. And so we try to use that in combination with some of the tools we'll be presenting to show that how it can be interpreted. Okay, Mel? So, for example, one particular location where we've tried to put three different ecological factors together, such as benthic surveys, chemistry from a large number, well over 100 different compounds, along with sediment toxicity measured at over 15 sites in the Houston Ship Channel, where we've used the sediment triad approach for that to try and tease out what is causing any of the toxicity and is it having any impact on the benthic communities. All right, Mel? Another example, or a couple of other examples that I mentioned before with the SEM modeling, was for dioxin accumulation in fathead and hardhead catfish in the Houston Ship Channel. In this situation, these 5 variables, the lipid content, sediment concentration, dissolved water concentration, site depth, and the time of the year, being represented by the Julian day number here, was able to explain 62% of the concentration in the tissues, and lipid content was the highest out of these at 47%. And then you can also see other correlations between these factors, such as lipid content correlated with sediment concentration, lipid content also correlated with dissolved water column concentrations. An example of the chemical correspondence analysis, or CCA, was for metals in a terrestrial environment. And this one utilized over 200 different factors, and we were able to explain 64% of the variability that we would see in this between the biological terrestrial plant species that were present versus site conditions, such as whether there was standing water, whether it was sand-dominated site, whether the land was managed, and soil moisture, as well as your environmental contamination, such as metals, etc. So as you can see, it's hard to explain a 3D or multiple dimension figure in a 2D world, but this is one example of where we've been able to do it before. In this case, whether the property was managed or not explained 31% of the species that we would find and any impact on those species. Okay, Mel? So, in summarizing this, Parsons tries to take these and complex modeling and statistical data tools and try to simplify them into something that resource managers, regulators, etc., can utilize to help make smart decisions and better decisions in working with the environmental situation where you're trying to manage and to, say, remediate, for example. In this way, we've been able to engage stakeholders and regulators by creating these various tools that help us evaluate the multiple options that are presented and try to get the biggest bang for your buck in this situation. Also, we've used it to promote adaptive management, to mitigate some of the uncertainties, and so that everyone understands what the uncertainty is in these processes. So therefore, we've tried to integrate stakeholders and people decision-making with the processes and the technology that's available out there to us in order to bring this all together. And so that's what we would like to try to show you in the next decision support tool example that Mel is going to present.
Okay, thanks, Randy. What I'm going to go through here is a specific example where we've employed these concepts. This is some examples of, some really exciting work that I think we're doing here at Parsons. It's one of the real fun things about working at Parsons, to be able to help clients, help stakeholders with these really complicated challenges. And just really enjoy the opportunities we've had to bring innovation to this arena. And hopefully I'm going to be able to demonstrate some of that here in the slides I go through. Now, all the examples I'm going to be walking through have been specifically applied to deal with surface water quality issues. But this concept of our decision support system that we've developed, we can also apply it, utilize it, implement it for terrestrial systems in terms of some of the examples Randy was talking about earlier regarding remediation issues or just other terrestrial aspects that need to be dealt with, or groundwater aspects too, because you'll see, I think we're following the same principles can be applied. So I'm going to, we've done this on 3 or 4 different surface water projects. I'm just going to show you a couple of them here real quick, but we're going to just focus on one specific one. But we've applied this decision support system approach for a municipal client in central Texas for the Upper Cibolo Creek watershed. Pretty small watershed, only 77 square miles, and the water quality issues there were bacteria and nutrients. And the underlying foundational model that we connected our decision support system to was SWOT, which is the watershed loading model. Whoops, wrong way. We've also done it on a much larger watershed. It's called the Leon River watershed, and it dealt with bacteria and nutrient issues, water quality impairments related to bacteria, excessive bacteria and nutrient loads. There, the underlying foundational model that we connected to was HSPF, which is, a watershed and in-stream pollutant fate and transport model. That was the underlying engine for that one. But the one I'm going to really focus on to show you our specific example today is the current project we're working on for a very large watershed up in northeastern Oklahoma for the Grand Lake of the Cherokees. It's a quite large 7,300 square mile watershed. The issues we're dealing with there are dissolved oxygen and nutrients, and the underlying modeling engine, if you will, is SWOT, which is the watershed loading model connected to the hydrodynamic model EFDC. And I just want to point out, kind of remember this, the reservoir image I have here, hopefully you can kind of see all these grid lines on the top of the surface water. That's the grid breakdown in EFDC. So we've divided the reservoir into 1,285 grid cells on the surface layer. But we also have, of course, the lake represented vertically in vertical profile. No cell or cells are divided into at least 2 depths, but some reach as many as 25 different cells in the vertical profile. So you can just put the math together and see the huge number of cells that the model represents to try and simulate the hydrodynamic nature and just the whole water process of the river, of the run of the river reservoir that this is. So just kind of remember that number, that 1285, as we go along. So what's been driving our need and desire to bring a different approach, some innovation to how we use and make decisions for environmental systems is really kind of what we've learned in the past using the traditional environmental model approach. I've kind of dubbed it myself. It's kind of the black box method. We as the consultant, we're hired by clients to come in and kind of do these first steps, get the existing data together, select and recommend which empirical or mechanistic model that we think is best for the system, build and adjust and calibrate the model or models. And then we as a consultant, we typically establish some hypothetical alternatives. We want to help the client understand how the system's behaving. a pre-impact condition, a current condition, and maybe one future condition we might suggest they look at. And, we do all the modeling in-house, and we crank away, and we come back to the client, and we say, okay, we've got the model ready. Now let's go report to all the stakeholders. And so we typically have a public meeting with a lot of different, representative stakeholders in the meeting, and we present the results of the model. And invariably, what we've learned happens oftentimes is stakeholders, regulators, even the client, it seems over and over things got focused more on the accuracy of the model. Even though we had always started out saying that, models are just tools, they're a broad brush in terms of giving you results, and given the limited amount of data every client, every consultant's faced with, there's always uncertainty in the model. And so it seemed like we always got bogged down in terms of the public meetings, justifying the assumptions in the model, how we dealt with uncertainty, why can't we get more data. So we always had to go back and do adjustments to the model and kind of do another run. And in the end, it was back to us to do that, kind of behind, back at the office. And we really could only answer more or less one answer. Did we meet the goal that we set out in terms of the hypothetical alternative we set up? It's kind of a yes or no answer. So as Randy mentioned earlier, through, kind of learning over time, we felt it important to try and find a different way to do modeling, a different way to help stakeholders. And what we always saw is three common drivers where we needed to find better ways to simplify very complex data that these models put out and huge volumes of data. We needed to figure out better ways to engage stakeholders up front and throughout the process. And we knew because of uncertainty and just the way environmental systems behave, we needed to help them understand, stakeholders and clients and regulators, how can we use models to advance the concept and statistical methods to advance the concept of adaptive management. And so this kind of represents what we evolved to in some of these projects that I mentioned earlier on, the three projects I have listed and that we're employing in this Grand Lake project. We brought the stakeholders in earlier. We had the client very engaged in helping us select the models. We had them very involved in defining what the management strategies were that they thought that were appropriate for the watershed conditions that they thought would be most appropriate for modeling and evaluating to understand, their impact on the land or the water quality or the environmental system in another situation. And so we moved into running more Monte Carlo simulations and to really focus in these surface water projects on characterizing loading and response ranges. And after we did that with the models, then you're going to see how the most of the rest of the presentation focuses on these last few boxes here, where we connect the DSS to the existing models. We allow the stakeholders to select the management scenarios they want to evaluate. And then we run the DSS, and then we compare the outputs. And if needed be, we can do this again. But the point is, we've turned the knobs of running the results process over to the stakeholders. And what we really did is we brought social science into the modeling process. We brought the public perspective or all of those hard to quantify variables when you're looking at things, what works best in a watershed. We brought a social science aspect into our DSS. And what we believe it's providing now is the platform and the real information you need for consensus on moving forward with implementation, not just defining what the scale of the problem is. So, and again, as you see over here, client and stakeholders are involved all the way through the process. So just to real quickly show you some examples. Again, this is Grand Lake over here on the left, okay? And if you remember the large number of cells that I mentioned that the hydrodynamic model gives you outputs for, these are some examples of what, really can be derived from a complex model like EFDC. You can get monthly surface DO variability for the baseline condition, and then you can compare it based on the cumulative BMPs or the best management strategies that you proposed to model or that you did model, and you can kind of do some comparison. Here you'll see this right here that we're tipping down. This is the goal. This orange line here is the goal you're aiming for. We had a violation here, basically, but as you can see under the pollutant run scenario where we're reducing pollutant loads, none of it gets close to it, so that's good. Here's the water column DO concentration graph, and here's an anoxic volume concentration graph. But think about this for a minute. You're going to have over 15,000 different graphs you could at any one time that you would have to digest, evaluate, and figure out how to present to clients, because one of these graphs represents every one of these cells throughout the reservoir. So that was our challenge. How do we take this very complex information that, sure, scientists understand how to interpret it, but it's not what regulators and stakeholders that live and work in the watershed need to help be engaged in the decision-making process. So we wanted to move away from this. What we saw as the need to focus on is we needed to help stakeholders understand that what we're aiming for, if this is the goal, this is for total phosphorus. Let's say this is the goal we've identified in the lake, that if we can get to this level of phosphorus concentration in the lake, we'll see a beneficial response in water quality, meaning, reduced algal blooms, higher dissolved oxygen concentrations. We had to explain to the stakeholders and the regulators that given uncertainty, we're aiming for a range. We're aiming for this sweet spot that we're trying to accomplish by implementing projects over time and an investment of dollars. And somewhere in here on this continuum is the sweet spot. And that's what stakeholders need. They need tools that can help them develop and evaluate multiple scenarios quickly and visualize those options and what they mean to them as a farmer, as a wastewater treatment plant operator, as a city manager for stormwater control, the costs and the benefit of doing project A, B, C, or D. So with that in mind, here's kind of just a real quick, simplistic user experience display of what the decision support system is that we connected to SWAT and EFDC. What we're going to allow the stakeholders or the client to do is come in here and on the computer click if they want to apply management strategies, best management practices to the Neosho Basin, which is this basin up here, or they can click and do it to the Spring Basin over here, or they can click it and select to do the Elk or the actual lake watershed, which just means the subwatersheds that drain right into Grand Lake. And I think I probably forgot to mention this earlier, but the huge watershed that we're dealing with steps into 4 different states: Kansas, Missouri, tiny bit of Arkansas, and of course downstream is Oklahoma. So they can either pick one of the watersheds, the big lake watersheds, or they can select individual subwatersheds, which are denoted by these outlines of the purple areas. Okay. Next step they can choose is they can choose which of these best management practices they want to see their pollutant load reduction effectiveness, okay, in terms of delivering loads to the lake and how the lake will respond. And so they can pick one of these, or they can pick all of them. They can pick them in a select geographic area or a, entire geographic area. And that's really what these little toggle buttons are here. And then when you have decided that, you click Run the Model. It runs the scenario, and you can save this particular scenario that you selected, okay? You say it runs that, you save it, and then the next step is we had to figure out how we wanted to be able to display the results from the DSS, and so we worked closely with the client and the stakeholders to decide, okay, what spatial level do we want to be able to represent the results in? And, you know, it was pretty straightforward, I think, because everyone kind of gravitated to the concept that when you're dealing with a lake this large and you're dealing with nutrient loads that will you want to manage better to improve dissolved oxygen levels in the lake, you need to look at it over a longer time scale, and you need to look at it at a larger surface water scale rather than those individual cells we were looking at. So collectively, they guided us to the decision. What they wanted is they wanted to see average water quality response metrics associated with the proposed management strategies for the upper lake, the middle lake, and the lower lake. So we designed the decision support system to give them annual average results for this portion of the reservoir above this tick mark, the middle reservoir, and then the lower reservoir down to the dam. And again, that was kind of a, you know, collaborative decision-making process there so that we would make sure we gave them the outputs that they wanted. So this is just an example. This is hypothetical. This is a tabular output that the DSS would deliver. Basically, it would show you baseline concentrate or loads. I'm sorry, this is loads. These will be presented in pounds per day. And so for each of the rivers, watersheds that we showed you earlier, it would give you the total nitrogen pounds per day based on the baseline existing condition. And then it will give you the reduction in loads based on the scenario that you saved, okay, for the BMPs that you as the stakeholder or the water resource manager selected. And it'll give you the new load in pounds per day and what that percent reduction is, okay? And then we did that for phosphorus and also. And then this is tables not filled out, but ultimately these will be populated based on the calculations that the tool will give you. And of course, you can click the save button and hit all this tabular data and save it as you need it so you can use the data to present. So this is another example of how we tried to figure out a way to simplify the data presentation and the data results in a manner that regulators, resource managers, the client, stakeholders could better interpret. If you remember, I talked about these two graphs over here on the right where we've got thousands of these based on the EFDC model. But in the end, all that really matters and what the stakeholders need to know is, under the baseline condition, is there a problem? And the answer is yes, there is a problem when it comes to anoxic volume of the overall reservoir. And that problem is manifested in the lower lake, where more than 50% of the volume in the lake can have an anoxic condition, which is a problem. You know, it creates problems in the lake in terms of water quality, but under the scenario that they saved, they see that the loading was reduced enough that the lake response was positive, and you're not going to see that. So this is a much simpler way we think, and in working with the client and the stakeholders, they understood this better rather than trying to interpret this. And then to really just kind of put it all together, this is just a, you know, basically a dashboard on the decision support output that the user will see after they've run everything. Again, the tabular results up here across the top. Here's other examples of, as I said earlier, there's water quality metrics that they decided that, you know, they thought were the best to show in terms of lake water quality response in response to all the BMPs you might be doing in the upper watersheds. They chose chlorophyll A as a criteria, as a parameter that they wanted to see results for, total nitrogen, and total phosphorus. And again, remember, all these are available in the model. They're there in the model. It's just thousands and thousands of plots you have to go through to kind of get to this point, and that's what we're trying to do, find a way to speed that up. And again, this is BMP scenario 1, and they could say BMP scenario 2, where they pick different results or different BMPs that they wanted to model. And then I just wanted to show this one down here. Basically, this is a representation so that different kind of stakeholder groups can better understand. Let me see if I can get this right. Yeah. They can kind of do comparisons to what the effectiveness of the different BMPs are so that they can better understand, where the best return on investment is, if you will, for investing in certain different BMPs. So if you are a wastewater treatment plant operator and we applied the technology limit of 1 milligram per liter phosphorus limit to all the dischargers that are over 1 MGD, you're going to get about a 12% reduction in nutrient loads, in phosphorus load to the reservoir. Whereas if you are say a row crop farmer, and a huge percentage of the watershed, contributing watershed, is in row crop farming, and you implemented 25-foot buffers along riparian areas that go through your cropland, you'd see approximately a 27% reduction from the baseline scenario in pollutant load. So it gives you a much easier, I think, method for understanding, what the results are of your management decisions. So that's really the concept of the decision support, taking very complicated data and putting in outputs that stakeholders, regulators, and the client can understand. And to kind of wrap up now, I just got 2 more slides here. This is really what's behind the decision support system. I don't expect anybody to read this. I don't want you to. All I'm trying to tell you is that there's a lot of computer coding, a lot of science, a lot of collaborative efforts goes on into trying to build the DSS to get it where we need it to be. And this just kind of shows the schematic game plan that we developed when we were envisioning this decision support system and as we built it. So to wrap up, kind of with some conclusions, both what Randy presented and what I presented here today. We're very committed and focused in employing innovative statistical methods and environmental models to help our clients. We know they're powerful tools that demonstrate to regulators, stakeholders, very critical factors that you're trying to understand in an environmental system, and they help you understand site-specific conditions that you're dealing with, because every project's different. But what we've learned is that complex models and the complicated science behind them has to be presented in a manner that managers and the public can better understand, so that they can use the information to build consensus to move forward and make good management decisions. We've, developed decision support tools that focus on providing users options and better information to guide what we think is the way to go, which is using the adaptive management approach. You have to be able to recalibrate and make sure, go back and see if what you're doing is working, and then tweak it as you go along. And we think these types of decision support tools allow you to integrate a lot of different criteria to be able to make these decisions. So in closing, Parsons, we're always going to strive to bring innovation to your projects. We love the challenge of multi-criteria decision making, applying that method and that concept when you're dealing with resource management, whether it be terrestrial or aquatic. And we look forward to working with any of you guys on trying to apply these kind of tools and concepts to help to make better decisions. So with that, I'm done, and I really appreciate all of your time.
All right, thanks, Mel and Randy. David, would you like to open the Q&A session, please?
Thank you. Everyone, your question and answer session will now begin. If you wish to ask a question, please key *1 on your telephone, unmute your device, record your name, then press the # key. If you then decide to withdraw your question, simply key *2. Alternatively, you may submit a question on the WebEx. To do this, please click on the 3 dots at the bottom of your screen, select the Q&A tab indicated, type your question, and click Send to all panelists. Thank you.
And I do see that we have a few questions already in the WebEx. I'm going to take one of these myself. Kevin Yu says, this is interesting material, and I was wondering if a copy of the presentation can be shared with participants. The webinars are recorded, and we do post them on Parsons' YouTube channel. Should be up on our channel by Friday, approximately. So if you want to look there, if you need a link to that, just send me a note at scott.hartzell@parsons.com, and I can send you a link when we get it loaded up there. All of the previous webinars, I think all of them for this year, are also up on YouTube if you want to look through any of the previous webinars as well. I should also mention that this webinar was approved for PDH and CEU's credits for those who are needing continuing education hours for a certificate or license, and so you can send me a note about that as well, and we will get you the sign-in form and get a certificate processed for you. Let's see, Yang Lee has asked a question, what is Parsons Statistical Toolbox that you mentioned in the presentation, and do we have such a toolbox available all across Parsons? Randy or Mel?
So, Randy, do you want to, I'll take a stab at that, and Randy, if you want to add on. In terms of Statistical Toolbox, Randy, I believe, was just indicating that we choose the tools we need based on the project, the issue and the complexity of what we're dealing with. But if I understand your question correctly, we do not have a set toolbox like on etc. that you would go to and grab those, predefined statistical methods. If I'm correct, Randy, can you confirm that?
Yeah, we have various individual software packages that we routinely use. I guess that collectively is considered our toolbox to use. But there's various packages that we have, such as the SEM, CCA, etc.
All right. Yang Lee also has a comment. Yes, a simplified presentation can be a powerful tool to deliver the complex modeling results. Agreement there. Eric Gowan asks, this is an excellent presentation. Who is Parsons' point of contact to help either internal or external clients get started with using models or developing model strategies?
Okay, so I would say you could probably start here in the Austin office. We would certainly do everything we can to direct you between Randy and I to make sure that we understand what the model or what the environmental issue is, what the aspect is you want to help both internally or clients with, and then we can help you kind of decide where to go within the company for the different expertise, because we do have, different folks across the company do have modeling expertise. We just have a lot of it here in the Austin office. So I'd say it'd be Randy and I would be a good place to start.
All right. Kevin also asked, does this concept get integrated with hydraulic models like Mike Shee?
It could.
This is the hydraulic models that you were showing, Mel, with SWAT and EFDC. That's similar to the Mike Shee hydraulic models, and so it certainly, we have certainly done that with the DSS.
Right.
Adil Chowdhury asks, very useful. Are there opportunities to tweak the model using, say, percent range for compliance of BMP that you would expect in the real world?
I think it's a good question, and I think the answer is absolutely yes. I will just tell you that the way what I presented today and the way this decision support, I call it a wrapper, or the dashboard that we've designed for the outputs I showed you. I do have to say that each one of them is somewhat of a custom design. So that concept you just asked about could certainly be incorporated. It's just a matter of we would have had to, think that through in terms of what data we need that the model already provides us, and then we just figure out how to create that as an output. That specific one, we hadn't gotten there yet with the client, but I certainly could see that might be something they want to see later on down the road.
Okay. We have one more question from Kevin. Has Parsons implemented DSS in the South Florida region?
We have not yet. Everything we've done really has been in the Texas, Oklahoma market at this point. We'd be happy to entertain that idea.
All right. So for our written questions on the WebEx, it looks like that's all we had. David, do you have any on the phone?
No questions in the queue, sir.
One more chance. Anyone out there have another question or comment? And if not, Mel, if you could advance one more slide. I want to let everybody know we do have another webinar scheduled for October. That will be October 14th, 12:30 again. We have Tracy Oathby and Amber Brenzicofer are going to be discussing a full-scale application of phytoremediation to address a 1,4-dioxane plume. So 1,4-D being a pretty new and emerging contaminant, and they've done a pretty interesting phytoremediation application there, so you'll definitely want to tie in for that. No other questions? Then I want to say thanks to Randy and to Mel. Great presentation, really enjoyed, and look forward to having everybody join us again next month. Thanks, everybody.
Thank you.
Thank you, everyone. That concludes your conference call for today. You may now disconnect. Thank you for joining. Enjoy the rest of your day.